Uh, the title is Beyond the Game Server, World of Tanks Console Platform Architecture. So I'm going to give you an overview of platform and what platform is, what it does, some of the engineering challenges that we've come across, and some takeaways. And I'm Eli Rosenberg. I'm a lead software engineer in the platform integration department at World of Tanks, Chicago, Baltimore. Quick show of hands. Can I get a show of hands? Who's an engineer or developer? Okay, good. Producers, designers? Okay, good. All right. So let's begin in the beginning and just give a quick definition. What is a platform? And basically, platform is just how we connect the game to the outside and the inside world. And as you can see in this blurry diagram here, it's very, very complicated, or at least it can be. This is a diagram, actually, of World of Tanks PC. The names have been changed to protect the innocent. Actually, I feel real bad for the person who has to maintain this diagram. But one thing that's interesting is World of Tanks PC grew very, very quickly in terms of the number of users and concurrent users and all the services and marketing and everything. So one lesson that I'm going to talk about a little bit later is that platform, and especially for free-to-play games, can be very organic. So that leads to some of the complexity that we see there. Quick introduction to World of Tanks console. Show of hands, anybody play World of Tanks or World of Tanks console? Okay. So World of Tanks console is not a port, it's actually a customized version. And one thing that's really cool about it that I would recommend you try out is if you have an Xbox One S or a PS4 Pro and you can hook it up to a HDR television, one of the newer 4K HDR televisions, I personally think the console version looks amazing in comparison to pretty much anything you can play on a PC at this point. The foliage and the tonal gradation is amazing. So anyway, I give you some numbers there as far as the scale. So it's a pretty big game. It's not as big as World of Tanks PC, but it's a pretty big game with a lot of concurrent users. It's a free-to-play game, and it is, since it's a console game, all of our transactions essentially have to go through Microsoft and Sony. So not unlike if you had a mobile game, you would have your transactions go through Apple or Google. So there's a lot of, in the platform department, integration with Microsoft and Sony. And another cool thing you can try is the War Stories mode, which is new and it's exclusive to console, which is another really cool thing about it being a customized game rather than a port, is you can play this War Stories, which is amazing in my opinion. So again, just quick introduction to, well, what's the console game? What's the core game as opposed to the platform? So the core game, at least per my definition, the core game is your renderer, which is Despair, your console client, which is your UI and your garage and all of that sort of stuff, the updater, which is quite complicated, updating the game. And the game server is Big World. And Big World manages the players, it manages concurrent worlds. Fun fact about Big World, I believe it holds the Guinness record for most concurrent users in a large multiplayer world, MMO. You can talk to Mikhail about that. He's an expert on large-scale game servers. So that's the core game. That's stuff that's not in platform, so stuff that I don't work on. But so now, why does platform matter? Why do we care so much about platform? Well, it connects the game with the outside world. So one really interesting thing is this promotion that they had on World of Tanks PC. And of course, you can't have a huge free-to-play game without some sort of cheesy promotion. So here's your cheesy promotion: is in World of Tanks, which is most popular in Russia. You could get a Tanko burger. Looks really amazingly appetizing, doesn't it? You could get a Tanko burger, and it would come with an IS-6 tank, a code essentially to redeem for an IS-6 tank. So you'd go on the website, punch in your code, you would get an IS-6 tank. And platform, and you would get 250 gold and so on and so forth. So platform handles that. Essentially, you go to the web, you enter the code, it makes sure you can only enter the code once, it makes sure you have a valid code, and you can't make up your own code. It does all of that management of the redemption code makes an invoice, and then stuff appears in the game. So platform handles that. It handles all the databases and all the details behind the scenes. So that's just one example of why it matters. Is it makes stuff like this run smoothly. I'm not going to run through all of these. These are just the kind of the list of the platform services. My favorites are the stats page. You can go to console.worldoftanks.com, check out the stats page in the Hall of Fame. And a really cool thing that was just released is replays. So we support the replays feature as far as cataloging where all the replays go. I would really recommend you check it out. I should have put a picture here. People have been finding really cool stuff in the replays. Like they find these birds that are flying through the world that you don't normally see, but they're actually rendered pretty nicely. You can check that on replays. Tournaments is also pretty cool. So that's just your list right there. So when you design a game, you kind of have a choice of what's your architecture, where are we going to put things. And in World of Tanks, PC, console, most of the wargaming franchise games, a lot of the services are outside the game. So why put the services outside of the game rather than integrate them into one game server or one package and then they all get released at the same time and you avoid some of the integration headaches? Well, the pros are mainly portability and scalability. And so as I mentioned there, there's the tooling is more mature, there's more developers, and you can separate all of the stuff that's not latency sensitive, that you can separate that out from your game loop and have that run elsewhere so that it can't possibly bring down your game or affect the latency or throughput or anything that's going on in your game. So that's the strategy that World of Tanks has taken. There are some cons though, which is, especially that we've had in our experience, our release management is a problem because all of these services that are not in the game, they have to be kind of synchronized in their capability with the game release. So we release them, sometimes on a different schedule, and there's a lot of integrations between services, and we have to, really communicate with the game server teams and the game design teams to make sure our services are in line with the requirements. Okay, so here's an example, and I'm not going to go through this in excruciating detail, but it just kind of goes through what happens when somebody makes a purchase request on the Xbox One. So Microsoft is the party that you have to make the purchase through. You can't, on a console game, take the credit card and do the transaction yourself because Microsoft is your partner in that case. So when the user, the player, makes a purchase request, Microsoft has a really secure system. It's pretty nice, but it does not provide invoicing. So you don't really get a record of what they purchased. So we have to go through a long sequence of events to essentially create the invoice, and magically everything will appear in your garage. If you buy a tank or buy a gold pack, it will appear. And so platform, just to give you an idea, platform is involved in this box here. We have an invoicing service, we have an inventory management service, and we have an authorization service which hands out tokens so that you can talk to Microsoft. And those intermediates talk to the game server, which will eventually make the item appear in the garage. So that's just an example of some platform services and how they help make sure that you get stuff when you buy it, because that's really important. Another one, which is, again, one of my favorites, and you can learn a lot about games. I myself, I'm not a huge gamer, but you can learn a lot about games just by checking out stats pages and learning. If you look at leaderboards, you can learn kind of what's important in the game or how people measure performance in the game, which gives you some insight if you're a new player. So I'd really recommend that you check out leaderboards, and they cause a lot of player engagement. A lot of people love the leaderboard. We have 1/7/28 day and all-time views, and you can sort them by any of these columns. So that's a really popular feature. And then, I didn't put the whole thing here, but you have stats breakdowns. You even have stats breakdowns by all of your tanks, by all the tier. So you can get a lot of feedback if you're into stats. Some people aren't into stats, but I personally love stats. So That's one of my favorites. So engineering stuff, great. So engineering challenges that we run into. So one thing that's really important when you're talking about services or microservices or is communication. And there's two main ways that we communicate between services, and those are HTTP and AMQP, which is a message queuing system. So HTTP, as most of us are aware, it's a peer-to-peer kind of protocol. It's synchronous. You have to wait. It's half duplex. And you can't do some of the more complex models of communication. But it works really well when you have a need for something that's kind of synchronous. A good example would be in this diagram here. A good example would be just when we asked Microsoft, hey, what is this user's inventory? What is this player's inventory? Like what gold packs do they have? What tanks do they have? The inventory manager just makes an HTTP request to Microsoft. It's very secure. It uses token authentication. It sits there. It waits. Microsoft collects their inventory from its internal databases and responds. So the inventory manager, not being kind of a latency-sensitive system, just handles that request synchronously. And it doesn't need any kind of full duplex communication or anything like that. So HTTP is great for those sort of things. And our HTTP stack that we commonly use Python, and it runs on Python's UISGI protocol. And then we use Nginx for load balancing, so we can do a lot of concurrent HTTP requests. Okay, and then the other way that we commonly communicate is AMQP, and like I mentioned. So AMQP is asynchronous, and that allows you to push stuff into a queue, which gives you buffering, which is amazing because, well, it's queuing. And you have different exchange types, so you can do multiplexing, which obviously you can't do with HTTP. And you can obviously be sending stuff in kind of a full duplex manner. Some of the downsides are obviously your architecture has to be able to handle an asynchronous model. And now, as in this example here, or this diagram here, you have centralization. So now you have a queuing server rather as a centralized service that you depend on. So you have to make sure that your queuing server is fault tolerant. And an example of stuff that we use AMQP for, so when you play a battle in the game server will push all kinds of information about the battle and about your account and about the stats that you have. It'll push that into a queue, because it's not like, it doesn't need to, interrupt the game. It's not critical in terms of the game. You can continue playing another game before that transaction is completed, so it pushes that into a queue, and then some internal services will handle that information that you pushed into the queue and eventually populate your stats in the web database. So that's a good example of when we use AMQP. So there's many other strategies you can use, or many other, shall I say, frameworks you can use to do communication, but they tend to fall into these same two models of request response and something that's more of a message queuing architecture. So that's kind of the dichotomy that you have. And one neat thing that's taking hold, unfortunately we don't have it too much support for it on the console, something called WebSockets. Allows full duplex HTTP communication, so that has a lot of advantages, and I'd say in 2 or 3 years we're going to be seeing quite a bit of that. Okay, so a continuation of the engineering challenges that we've run into. Things you have to really consider are, you have to consider your concurrency model. How are you going to handle a lot of simultaneous transactions? Users are constantly buying stuff, users are constantly playing battles, exporting stats. Users are constantly making battles that create replays, they're creating tournaments, authorization. I mean, there's lots and lots of transactions going. So you have to manage those concurrently. How much hardware do you want to use? How much storage do you want to use? So you have to have a good architecture in mind. And very few things are CPU bound. It's all about I/O and concurrency. And of course, databases. You have to think about how are you going to persist information? How are you going to log things? How are you going to handle stuff for customer service so that, if the user needs a refund, everything, has to have a good logging system and clawback. And one thing that we've run into quite commonly is data in the game is stored in a format that's optimized for the game. It's maybe not optimized to use in sort of what I would call an e-commerce setting, or the setting that we typically use in a web department. So there's a lot of communication involved with talking to the game team and figuring out how their data is stored, how do we get it out and put it in a ETL, so to speak, into our systems and get it in a way that's optimized for the web. Okay, so some of the lessons that we have learned. So platform is great in that you can support your game features. It's really great for player engagement, stuff like the stats. We have a great customer service app, and separating all that from the game kind of gives the game polish, and allows the game server teams to kind of focus on the game. So one thing that I've alluded to before, free-to-player games, their content is king. So the game is constantly evolving, and with that constant evolution, especially when the game grows in size, there's constant challenges in terms of growing out the service stack to support that. So one thing you should have as a takeaway is, if you're going to do a free-to-play game, all bets are off what it's going to. If it becomes a success, all bets are off what it's going to look like a couple of years down the line. So be prepared, in terms of portability, scalability. Be prepared. Process management is a big thing. Release management is a big thing that we run into. So you want to have strong integration between anybody who's working outside of the game server and the people working in the game server. And so the future, so platform is a pretty big thing, because to publish a game nowadays, you need a web presence, you need to work with all of the authorization schemes, you need to have, especially if it's a free-to-play game or any kind of game with microtransactions, you need a way for people to buy stuff. It's a big thing. So two things that I would take note of for the future, there's something called Amazon Game Lift, which provides services so that you can publish a game, and Wargaming has already partnered with them for some of the mobile publishing. And there's another interesting one that's platform as a service called PlayFab. And PlayFab provides a lot of kind of out-of-the-box solutions. If you publish your game with PlayFab, they provide you a lot of those out-of-the-box solutions in terms of purchasing and web presence. So that's kind of the future, is more modularization of platform. Okay, so just in conclusion, think beyond the game server. Think about what you could do for your players beyond just your game loop and your game economy. Think about what you could do for them. And it's a pretty big deal at Wargaming. There's a new effort at Wargaming, something called Platform 2.0, which is taking all the lessons they learned from this mess, which does work great. It's just iteratively taking the lessons they've learned and putting that towards a new platform. And that's allowing them to publish new games from third-party studios. So Total War Arena is coming out, and that's going to be published by Wargaming, and it's going to use a lot of Wargaming assets from Platform 2.0. So that's all I got for you. Thanks for coming, and time for questions. Yes?
So you released on a couple different platforms. What has been the most problematic third-party e-commerce system you've worked with, Microsoft or others?
Yeah, so there's pluses and minuses to each one. So Microsoft and Sony, they do things somewhat similarly. The main thing that I alluded to is they don't provide an invoice. So in my opinion, the way that they manage user digital goods is simplistic. It's secure, but it's very simplistic. So in other words, it only tells you, hey, this guy's got 2 fire extinguishers. If you buy a 3rd fire extinguisher, it'll tell you this guy has 3 fire extinguishers. It won't tell you this person has just purchased a fire extinguisher. So you have to do a lot of the logic yourself. So in other words, it's very simplistic I think it's, in my opinion, it could be improved in terms of how it handles commerce. But you have to also keep in mind that a free-to-play game like World of Tanks console, It's not unique, but it's newer in the console space. So in the mobile space, you know, free-to-play games, microtransactions, you know, that's been around. But as far as, you know, Microsoft and Sony and console games, it's a little bit unique. So hopefully they will improve the way they handle commerce. But I mean, it works for us. You know, it's just got some complexity there. So they both work quite similarly. Any other questions? Tom, you had a question, didn't you?
I was going to ask if, when you mentioned WebSockets, did you see a shift going from AMQP to that? Like, would you like to see even more web and move away from message bus?
Well, I think there are situations where people rush to using AMQP and message queuing, where if they had WebSockets available, they would probably still be able to use HTTP. And I'm not saying one is better than the other, but there's some simplicity in HTTP and a lot of the tooling that's out there. Just maybe more developers are familiar with it. So yeah, still with WebSockets, you can't do things like multiplexing. You know, it doesn't do that for you. But once you have WebSockets, you can have full duplex communication. You can do a little bit more of pushing. So with typical HTTP, you can't push a message to the player, or the client, I should say. You can't push a message to the client. The client has to request and wait. But once you have a full duplex communication, you can do a little bit more complicated stuff, a little bit more media-related stuff. Anything else?
Just one more question about
Yeah.
your infrastructure.
Yeah.
On the back end, do you use relational databases, document-oriented like NoSQL, or a mix of the two?
So for the most part, we use relational databases. Most of our stuff is, some of our stuff is simple. We could use a non-SQL database, but we measured performance, and usually the database is not typically a limiter, so we just go with like a Postgres database, and that typically works fine. Now, one thing I did mention is you may at times need to, when you have millions of users, you may need to partition or shard your databases, and that probably would apply if you use non-SQL or document-oriented storage. So, you know, typical engineering advice, you know, measure and don't over-engineer before you have to. That's kind of the stance we usually take in our department, is start simple, measure. If that doesn't meet our requirements, iterate. All right. All right, thank you guys for coming.